They thought she was just another mechanic fixing broken engines in a dusty hangar. What they didn't know was that Elena Vasquez was quietly rebuilding the most classified stealth technology the military had ever developed, using nothing but spare parts and a mind that could see possibilities where others saw only problems. Preparing and narrating this type of story took us long efforts and hard work. So if you are enjoying the story, please consider subscribing to our channel. The desert wind howled across Edwards Air Force Base as Elena stepped off the transport bus, her worn canvas bag slung over one shoulder and her discharge papers folded neatly in her jacket pocket. 28. She carried herself with the quiet precision of someone who had learned to move carefully through hostile territory, both literal and metaphorical. Her dark hair was pulled back in a practical bun, and her calloused hands spoke of years working with complex machinery under impossible conditions. Master Sergeant Reynolds barely glanced up from his clipboard as she approached the civilian contractor check-in station. "Another mechanic transfer," he muttered to his assistant, scanning Elena's paperwork with practiced indifference. "Says here she's got aircraft maintenance experience. Small engine repair specialist." He stamped her forms without enthusiasm. "Great, another grease monkey who thinks she knows jets." Elena said nothing as she shouldered her bag and followed the assistant toward the maintenance hangars. She had learned long ago that first impressions were rarely worth correcting, and military installations operated on assumptions that could take months to change. Her transfer documents read exactly what they were supposed to read: former aircraft maintenance technician seeking civilian employment with defense contractors. What they didn't mention was the 4 years she had spent as the primary systems engineer for the Air Force's most classified stealth aircraft program, working alongside engineers who possessed security clearances so high their own families didn't know what they did for a living. The maintenance facility at Edwards buzzed with activity that spoke of serious government contracts and unlimited budgets. Massive hangars housed aircraft in various stages of repair and modification, while teams of skilled technicians worked on everything from vintage fighters to cutting-edge experimental prototypes. The civilian contractors here were the elite of aerospace maintenance, former military personnel who commanded six-figure salaries for their expertise with advanced aircraft systems. Chief Maintenance Supervisor Patricia Wong barely looked up when Reynolds introduced Elena at the main repair bay. Wong was a formidable woman in her 50s, with silver-streaked hair and the no-nonsense demeanor of someone who had earned respect in a male-dominated field through pure competence. "Put her on basic engine maintenance," Wong said dismissively, gesturing toward a row of partially disassembled aircraft engines. "Let her clean components and learn how we do things here. Maybe she'll pick up something useful watching the real technicians work." Elena nodded politely, filing away the casual dismissal alongside countless others she had received throughout her career. At 5'4" and barely 130 pounds, she had never fit anyone's image of what an aerospace engineer should look like. The military had strict physical standards for certain technical specializations, standards that had prevented official recognition of her contributions regardless of her intellectual capabilities. But expertise didn't disappear simply because regulations couldn't acknowledge it. Her assigned workspace was functional but cramped. A metal workbench, basic tools, and access to the parts inventory system. While other technicians worked on complete aircraft systems, Elena was expected to focus on component-level maintenance and cleaning procedures. The work was routine, almost meditative, but it also provided perfect cover for observation and analysis. During her first week, Elena methodically examined every piece of equipment that passed through her station. Turbine blades with microscopic stress fractures that indicated metal fatigue patterns. Fuel system components showing wear characteristics that revealed operational histories. Electronic assemblies with modifications that suggested performance enhancement beyond manufacturer specifications. Each component told a story about the aircraft it came from, and Elena read those stories with the focused attention of someone trained to extract critical information from seemingly mundane details. "You planning to memorize every part number?" asked James Chun, the technician working at the adjacent bench. James was everything Elena appeared not to be: tall, confident, and loud about his qualifications. He had arrived 6 months earlier, with stories about his previous job maintaining corporate jets and dreams of working on classified military projects. "Just trying to understand the inventory system," Elena replied quietly, making notes about thermal stress patterns on a damaged compressor blade. James laughed and shook his head. "Understanding and doing are completely different things. Wait until you see the complexity of the systems we work on here. Theory doesn't mean much when you're troubleshooting a multi-million-dollar prototype that the Pentagon needs operational tomorrow." Elena almost smiled at his assumption. Multi-million-dollar prototypes. She had spent 4 years ensuring that billion-dollar aircraft remained invisible to enemy radar while operating in conditions that pushed the boundaries of materials science and aerodynamics. The next morning brought her first glimpse of the facility's true purpose. Deep within the secure section of the complex, accessed only by personnel with the highest security clearances, experimental aircraft underwent modifications that weren't discussed in official reports. Elena caught brief glimpses through reinforced windows, sleek, angular shapes that seemed to absorb light rather than reflect it, aircraft designs that appeared decades ahead of anything in public service. "Curious about the classified section?" asked Dr. Sarah Mitchell, the facility's senior aerospace engineer, noticing Elena's interest. Mitchell was an impressive figure with multiple advanced degrees and a reputation for solving impossible engineering problems. She wore her credentials with quiet confidence, the kind of assurance that came from years of recognition and professional success. "That's where the real work happens. Advanced propulsion systems, stealth technology integration, materials research that won't be declassified for decades." Elena nodded respectfully, not mentioning that she recognized several of the aircraft configurations from her previous assignment. The stealth fighters she could see were variants of projects she had helped develop, incorporating radar-absorbing materials and engine modifications that she had personally designed and tested. "It must be fascinating work," she said instead, maintaining the role of curious newcomer. During her second week, Elena began noticing patterns that troubled her professionally. Equipment failures that shouldn't occur with proper maintenance. Protocols. Engine components developing performance issues that indicated systemic problems rather than random mechanical failures. When frustrated technicians brought problematic assemblies to the repair bay, Elena found herself analyzing failure modes with an intensity that drew curious glances from her colleagues. She had an uncanny ability to diagnose complex problems that stumped more experienced technicians. Microscopic bearing wear that indicated lubrication system failures. Electronic component degradation that suggested power supply irregularities. Stress fractures in titanium alloys that revealed operational parameters exceeding design specifications. Skills that seemed almost supernatural to observers who didn't understand the depth of her technical background. How does she spot these problems so quickly? Marcus Webb asked Wang after watching Elena identify a hairline crack in a turbine blade that had been causing mysterious power fluctuations. "Lucky guess," Wang replied, though her tone suggested growing curiosity about Elena's diagnostic capabilities. "Some people have a good eye for detail." Elena said nothing about her analysis methods. She had developed these skills through necessity, working with aircraft systems where component failure could mean the difference between mission success and catastrophic loss of billion-dollar assets. When you were responsible for ensuring that experimental stealth technology functioned perfectly under combat conditions, you learned to read mechanical systems like others read books. Late at night, while other technicians socialized or went home to their families, Elena studied technical manuals and engineering documents that she requisitioned through legitimate channels. Advanced materials science texts, propulsion system research papers, electromagnetic theory publications that most mechanics would find incomprehensible. Her colleagues assumed she was trying to improve her technical knowledge to qualify for better assignments. But Elena was actually staying current with developments in fields where she had once been a leading contributor. Her apartment was spartanly furnished but filled with technical references that told the story of someone deeply committed to understanding aerospace engineering at the most fundamental levels. Texts on computational fluid dynamics sat beside manuals on radar cross-section reduction. Research papers on advanced composite materials were bookmarked alongside theoretical discussions of plasma stealth technology. The breadth and depth of her library would have impressed university professors, but Elena studied alone, maintaining the careful invisibility that had protected her throughout her military career. What her colleagues didn't know was that Elena had been part of a classified program so sensitive that its existence was denied by official sources. Project Silent Eagle had developed stealth technology decades ahead of acknowledged capabilities, creating aircraft that could operate undetected in hostile airspace while carrying payloads that conventional wisdom said were impossible. Elena had been the primary systems integration engineer, the person who made theoretical advances practical and operational, but regulations had prevented official recognition of her contributions. Without the required advanced degrees and formal engineering credentials, she had been classified as technical support personnel despite designing solutions that senior engineers couldn't conceptualize. Her innovations had been attributed to team leaders who possessed proper qualifications, while Elena remained invisible in official documentation. The irony wasn't lost on her that the same system capable of creating technological miracles often ignored the people who made those miracles possible. But Elena had made peace with anonymity years ago. Recognition mattered less than the work itself, and the satisfaction of solving impossible problems was reward enough for someone who understood that true innovation happened in shadows rather than spotlights. As her third week at Edwards began, Elena sensed opportunity in the complex challenges surrounding her. The facility's focus on advanced aircraft systems, the emphasis on pushing technological boundaries, the constant pressure to maintain aircraft that operated at the edges of possibility, all of it called to expertise she had developed in classified programs that officially didn't exist. Somewhere in the secure section of the complex, experimental aircraft awaited modifications that would determine America's aerospace dominance for decades to come. Elena looked through her apartment window at the desert stars and wondered if her knowledge might once again prove essential when conventional approaches reached their limits. After all, technological breakthroughs weren't achieved by people who followed established procedures. They came from individuals who understood that innovation required looking beyond surface assumptions and recognizing expertise wherever it appeared. Regardless of credentials or official recognition, the morning sun blazed across the desert as Elena approached her workstation, carrying a thermos of coffee and the technical manual she'd been studying the night before. 3 weeks into her assignment, she had settled into a routine that kept her productive but unremarkable, exactly the balance she preferred. While senior technicians worked on complete aircraft overhauls, she maintained her focus on component-level diagnostics and repair procedures that others considered mundane. Vasquez called Supervisor Wong from across the maintenance bay, her voice cutting through the ambient noise of pneumatic tools and running engines. "We've got a problem with the new batch of turbine assemblies. 6 different engines showing performance degradation after installation. Corporate wants answers before the Pentagon starts asking questions." Elena nodded and began her systematic inspection of the problematic components. Within minutes, she had identified the source of the failures. Improper heat treatment during manufacturing had created microscopic stress points in the titanium alloy blades. The defects were invisible to standard inspection procedures, but would cause catastrophic failure under sustained high-temperature operation. The fix required precise thermal cycling to restore proper molecular structure, a procedure most technicians had never encountered. "How the hell did you diagnose that so fast?" muttered senior technician Rodriguez, watching over Elena's shoulder as she outlined the necessary repair procedures. Rodriguez was a 20-year veteran with extensive experience in military aircraft maintenance, but he had never seen component analysis performed with such systematic precision. "Just methodical troubleshooting," Elena replied quietly, not mentioning that she had encountered similar manufacturing defects during her work on classified stealth programs where component failure could compromise entire missions. The repair process Elena recommended was unconventional but effective. Using controlled heating cycles and specialized cooling procedures, she restored the turbine blades to proper operational specifications. The technique wasn't found in standard maintenance manuals because it required understanding material science at a level most mechanics never achieved. Elena had learned these methods through necessity, working with experimental alloys that pushed the boundaries of aerospace engineering. "Impressive work, Vasquez," Wong admitted, reviewing Elena's repair documentation. "But don't let it go to your head. Component repair is different from system integration. The real challenges happen when you're working with complete aircraft assemblies under operational pressure." Wong's dismissal carried the tone of someone protecting established hierarchy, but Elena sensed genuine curiosity beneath the professional skepticism. The supervisor had built her career on competence and practical experience, rising through ranks dominated by men who questioned women's technical capabilities. She recognized expertise when she saw it, even when it appeared in unexpected packages. Later that afternoon, Elena observed advanced technicians struggling with a complex diagnostic challenge that was backing up the entire production schedule. A prototype aircraft was experiencing mysterious power fluctuations that affected stealth systems operation, but conventional troubleshooting had failed to identify the source. The aircraft was scheduled for classified testing in 72 hours, and delays would impact Pentagon evaluation schedules that couldn't be modified. "Must be electromagnetic interference from the new avionics package," suggested Chen, studying readouts that showed erratic power distribution patterns. "The stealth systems are probably conflicting with navigation electronics." His analysis was logical based on standard aircraft systems, but Elena could see fundamental flaws in his reasoning that would lead to hours of unproductive investigation. The power fluctuations weren't caused by electromagnetic interference. Elena recognized the signature of a more subtle problem: microscopic vibrations in the engine mounting system were creating harmonic resonance that affected sensitive electronic components. The issue was mechanical rather than electrical, requiring structural analysis rather than avionics troubleshooting. She had encountered similar problems during stealth aircraft development, where maintaining electronic system stability was critical to operational effectiveness. "Actually," Elena said carefully, approaching the senior technicians with appropriate deference, "the power fluctuation pattern suggests mechanical resonance rather than electromagnetic interference. The frequency analysis indicates structural vibration at a harmonic that would affect sensitive components." Her observation was delivered quietly, without challenging anyone's authority directly. Chung looked at her with obvious skepticism. "Mechanical resonance? That's pretty advanced analysis for someone working component maintenance. What makes you think you understand system-level integration better than certified avionics specialists?" Elena felt the familiar weight of being questioned about expertise. She couldn't fully explain without revealing classified background information. "I've observed similar patterns in previous assignments," she replied diplomatically. "The frequency signatures are consistent with mounting system harmonics rather than electronic interference." Previous assignments, Rodriguez repeated mockingly. Right, because aircraft maintenance at some regional airport obviously prepared you to troubleshoot multi-million-dollar stealth prototypes. The sarcasm in his voice carried undertones of frustration that their conventional approaches weren't working, combined with resentment that solutions might come from someone they considered unqualified. Elena remained silent, but her analytical mind was working furiously. She could see exactly what modifications would eliminate the harmonic resonance problem, but suggesting structural changes to classified aircraft systems would violate numerous protocols. Her unofficial status meant that technical recommendations could be dismissed as overstepping boundaries, regardless of their accuracy. That evening in the facility cafeteria, conversations centered on the day's diagnostic challenges and mounting pressure from Pentagon oversight. This is getting ridiculous, complained Martinez, a senior systems specialist with 15 years of experience. We've got the most advanced diagnostic equipment available, but we can't solve a simple power fluctuation problem. Maybe it's not as simple as we assumed, suggested Lisa Park, one of the few other women working in the technical section. Lisa was a communications systems expert who had befriended Elena during their lunch breaks, recognizing a kindred spirit in someone who preferred listening to talking. Sometimes problems that seem straightforward are actually symptoms of more complex issues. Elena sat at a nearby table, reviewing technical specifications for the troubled aircraft while listening to her colleague's speculation. She knew exactly what was causing the power fluctuations and could implement a solution within hours if given access to the aircraft. But speaking up would require revealing knowledge that went far beyond her supposed experience level. You look like you have opinions about today's challenges, Lisa observed quietly, joining Elena at her table. It's frustrating watching capable people struggle with preventable problems, Elena replied carefully. But offering unsolicited technical advice rarely improves workplace relationships. Maybe not officially, Lisa said thoughtfully. But if you have insights that could help solve critical problems, wouldn't sharing them be more important than maintaining social protocols? Her question carried genuine curiosity rather than professional challenge, suggesting someone who valued competence over hierarchy. That night, Elena made a decision that would change her trajectory at Edwards Air Force Base. She waited until the maintenance facility was empty, then used her access credentials to examine the problematic aircraft directly. The security systems recorded her presence as routine equipment inspection, a legitimate activity for maintenance personnel during off hours. Working by hangar lighting, Elena performed detailed analysis of the aircraft's mounting systems and structural configuration. Her suspicions were confirmed within minutes. The engine mounts had been installed using standard procedures appropriate for conventional aircraft, but the stealth prototype's unique weight distribution created harmonic frequencies that interfered with sensitive electronics. The solution required repositioning mount points by precise measurements that would eliminate resonance without affecting aircraft performance. The modifications Elena needed to make were subtle but critical. Adjusting mount positions by millimeters, adding damping materials in specific locations, recalibrating electronic systems to account for structural changes. Work that would take her less than 3 hours, but would require explaining knowledge she wasn't supposed to possess. She was completing her analysis when footsteps echoed across the hangar floor. Dr. Mitchell emerged from the administrative section, carrying files that suggested she was working late on critical project documentation. Her expression was unreadable in the dim lighting, but Elena sensed she had been observed longer than the footsteps indicated. "Working late, Vasquez?" Mitchell asked, though her tone suggested she already understood what Elena had been doing. "Just reviewing the power fluctuation problem," Elena replied carefully. Sometimes fresh perspective helps identify solutions that conventional approaches miss. Mitchell studied her for a long moment, clearly evaluating what she had witnessed. That's a very sophisticated analysis you were conducting. Most component maintenance technicians wouldn't recognize harmonic resonance patterns, much less understand how to correct them through structural modification. Elena's heart rate increased as she realized her cover might be compromised. "I've had some experience with vibration analysis in previous positions," she said, trying to maintain her established background story while acknowledging obvious expertise. "Previous positions," Mitchell repeated thoughtfully. "Your personnel file is interesting reading, Vasquez. Former military aircraft maintenance with commendations for technical innovation, but very little detail about specific assignments or projects." She paused, clearly weighing her next words carefully, almost like someone with classified background who couldn't discuss their actual experience. The observation hung in the air between them like an accusation and opportunity combined. Elena remained silent, uncertain whether she was being exposed or evaluated for possibilities she hadn't considered. "The Pentagon is sending evaluation teams next week," Mitchell continued. "If we can't solve this power fluctuation problem, contracts worth hundreds of millions of dollars could be canceled. National security programs could be delayed for years, while we develop alternative solutions." She gestured toward the aircraft Elena had been examining. "Sometimes desperate situations require unconventional approaches from people who understand problems others can't even recognize." Elena sensed that her carefully maintained invisibility was about to end, whether she wanted it to or not. The question was whether her expertise would be revealed as an opportunity or a liability in an environment where credentials mattered more than capabilities. The following morning brought an uncomfortable shift in dynamics that Elena felt before. She even reached her workstation. Word of her late-night analysis had somehow spread through the maintenance facility, creating an undercurrent of speculation and suspicion that made routine interactions awkward and strained. She arrived to find several senior technicians clustered around the problematic aircraft, their voices carrying undertones of defensive frustration. "I still think it's an avionics issue," Chun was saying loudly, his words aimed more at establishing authority than solving problems. "These new electronic warfare systems are notoriously sensitive to electromagnetic interference. We just need more sophisticated shielding protocols." Rodriguez nodded aggressively. "Exactly. Some people think they can waltz in here with amateur theories about structural engineering, but this is advanced aerospace technology. You don't troubleshoot stealth systems by playing with engine mounts like you're working on a crop duster." Elena understood she was being discussed without being directly addressed, a passive-aggressive approach that allowed criticism without confrontation. She focused on her assigned component maintenance tasks, methodically cleaning and inspecting parts, while listening to conversations that revealed more about workplace politics than technical understanding. Dr. Mitchell appeared at Elena's workstation. Mid-morning, carrying a thick folder and wearing an expression that suggested important decisions were being made. "Vasquez, I need you to prepare a detailed technical report on your harmonic resonance analysis. Include structural modification recommendations, expected performance improvements, and implementation timeline." The request was delivered loudly enough for nearby technicians to hear, clearly intentional. Elena felt multiple conversations pause. As colleagues processed the implications of a component maintenance worker being asked to provide system-level technical documentation. "Yes, ma'am," she replied professionally, though her mind was racing through the complications this would create. "This is getting interesting," Lisa whispered during their lunch break, settling beside Elena at their usual corner table. "Word is that Mitchell spent 3 hours on secure phone calls this morning, talking to people with clearances above her level. Whatever you said or did last night got serious attention from serious people." Elena picked at her sandwich, appetite diminished by growing awareness that her situation was changing in ways she couldn't control. "I just provided some technical observations, nothing that should require involving outside oversight." But even as she spoke, Elena knew her analysis had been too accurate and too sophisticated to dismiss as routine mechanical troubleshooting. The afternoon brought an unexpected visitor that confirmed Elena's suspicions about escalating attention. Colonel Marcus Sterling arrived without fanfare, but his presence immediately elevated tension throughout the facility. Sterling was legendary within aerospace circles, a former test pilot turned program manager who oversaw the military's most classified aircraft development projects. His appearance at Edwards meant that someone very important was taking the power fluctuation problem seriously. Elena watched from her workstation as Sterling toured the maintenance facility with Mitchell and Wong, asking detailed questions about personnel capabilities and project timelines. When the group approached her area, Elena focused intently on the turbine blade she was inspecting, hoping to avoid direct attention. "This is Elena Vasquez," Mitchell said, clearly not allowing Elena to remain invisible. "She's the technician who identified the harmonic resonance issue I mentioned in my report." Sterling studied Elena with the calculating gaze of someone accustomed to evaluating capabilities quickly and accurately. His weathered face bore the confident lines of a man who had pushed experimental aircraft beyond their design limits and lived to analyze the results. "Interesting analysis, Vasquez," Sterling said, his tone carefully neutral. "Harmonic resonance affecting electronic systems isn't something most maintenance personnel would recognize, much less propose structural solutions for." His words carried the weight of someone who understood both the technical complexity involved and the implications of Elena's insights. "Just applying systematic troubleshooting methods, sir," Elena replied carefully, maintaining appropriate respect while avoiding claims about expertise she wasn't supposed to possess. Sterling nodded slowly, but his expression suggested he was processing information beyond what Elena had actually said. "I'll want to review your detailed technical report," he continued. "Sometimes fresh perspectives reveal solutions that conventional thinking misses." The comment was delivered as professional interest, but Elena detected undertones of evaluation that made her uncomfortable. Sterling's reputation included an ability to identify exceptional talent regardless of its packaging or official credentials. That evening, Elena worked late preparing the technical documentation Mitchell had requested. The report required explaining complex engineering concepts in terms that wouldn't reveal classified knowledge while providing sufficient detail to guide implementation. She walked a careful line between demonstrating competence and maintaining her cover story about routine mechanical experience. Her analysis documented the precise frequency characteristics of the harmonic resonance, explained how engine mount positioning created destructive interference with electronic systems, and outlined modification procedures that would eliminate the problem without affecting aircraft performance. The work required understanding aerospace engineering at a graduate level, but Elena presented it as practical troubleshooting rather than theoretical analysis. As she wrote, Elena reflected on the irony of her situation. For years she had provided similar technical solutions while working on classified programs, but her contributions had been attributed to senior engineers who possessed proper credentials. Now she was being asked to document expertise officially, creating permanent records that would either validate her capabilities or expose knowledge she wasn't supposed to have. The next morning brought consequences Elena had anticipated, but hoped to avoid. Chun approached her workstation with obvious agitation, carrying printed copies of her technical report and wearing an expression of wounded professional pride. "This is quite a document you prepared," he said, his voice carrying dangerous undertones. "Pretty sophisticated analysis for someone with basic maintenance qualifications." Elena continued her work without looking up, recognizing the opening of a confrontation she couldn't win through direct engagement. Dr. Mitchell requested specific information about the resonance problem. I provided what technical analysis I could based on observable symptoms. "Observable symptoms," Chun repeated mockingly. "Right. Because frequency analysis and structural modification recommendations are just common-sense maintenance procedures. He slammed the report down on Elena's workbench hard enough to scatter her tools. Where did you really learn this stuff, Vasquez? Because your personnel file doesn't show any education or experience that would justify this level of technical sophistication. Other technicians were gathering to observe the confrontation, sensing workplace drama that would provide entertainment and potentially reshape established hierarchies. Elena felt the familiar weight of being challenged about expertise she couldn't fully explain without compromising security protocols that still bound her years after leaving active duty. I've had diverse maintenance experience across different aircraft types, she replied diplomatically, trying to diffuse tension without backing down from her technical conclusions. Sometimes patterns become apparent when you've seen enough different systems. Rodriguez joined the confrontation, clearly supporting Chun's challenge to Elena's credibility. Diverse maintenance experience? Your record shows routine component work at regional installations. Nothing that would expose you to advanced stealth technology or harmonic analysis techniques. The accusation was delivered loud enough for the entire maintenance bay to hear, effectively putting Elena's competence on trial before an audience of colleagues who would judge her based on this confrontation. She felt trapped between revealing classified background information and allowing her expertise to be dismissed as fraudulent. Maybe we should let the technical results speak for themselves, Elena suggested quietly. If my analysis is correct, implementing the modifications will solve the power fluctuation problem. If I'm wrong, conventional troubleshooting methods can continue. That's not the point, Chun shot back, his frustration boiling over into open hostility. The point is that maintenance personnel don't develop structural engineering solutions for classified aircraft systems. Either you're hiding qualifications that should be in your personnel file, or you're making educated guesses and hoping nobody calls your bluff. The confrontation was interrupted by Wang's authoritative voice, cutting across the maintenance bay. What's the problem here? She demanded, approaching with the no-nonsense expression of a supervisor dealing with workplace disruption. Her presence immediately elevated the conflict from personal disagreement to official workplace issue. Just discussing technical approaches to the resonance problem, Elena replied carefully, not wanting to escalate tensions further by making accusations against her colleagues. But Chun wasn't willing to let the matter drop without achieving some resolution to his challenges. Wang, we need to know where Vasquez really learned the advanced engineering techniques she's claiming to understand, Chun said, appealing to supervisory authority to force disclosure Elena couldn't provide. Her technical report reads like graduate-level aerospace engineering, but her background shows basic maintenance qualifications. Wang studied Elena with renewed interest, clearly processing implications she hadn't previously considered. The supervisor's expression suggested someone recalculating assumptions about personnel capabilities based on new information that didn't fit established patterns. Vasquez, step into my office, Wang said finally. We need to discuss your background and qualifications in more detail. The words carried formal weight that transformed workplace speculation into official investigation. Exactly the scrutiny Elena had spent her career trying to avoid. As Elena followed Wang toward the administrative section, she felt the weight of concealed expertise becoming impossible to maintain. The technical knowledge that had made her invaluable in classified programs was now threatening to expose secrets that could end her civilian career before it properly began. Behind them, conversations erupted among the remaining technicians as they processed what they had witnessed and speculated about revelations that might emerge from Wang's investigation. Elena's carefully maintained invisibility was dissolving. Whether she wanted it to or not, Wang's office was a study in organized efficiency, with technical manuals arranged precisely on metal shelves and performance charts covering one entire wall. Elena settled into the uncomfortable chair across from Wang's desk, while the supervisor pulled her personnel file from a secure cabinet, the folder notably thinner than those of other technicians with similar experience claims. "Let's start with the basics, Vasquez," Wang said, opening the file and spreading its contents across her desk. "Your discharge papers show 4 years active duty, aircraft maintenance specialty, honorable discharge with commendations for technical innovation. But there's something interesting about the gaps in your service record." Elena maintained neutral composure while her mind calculated how much information she could reveal, without violating security oaths that remained binding years after her discharge. "I served at several installations during my enlistment. Some assignments involved classified programs that don't appear in standard personnel documentation." Wang leaned back in her chair, studying Elena with the sharp attention of someone who had navigated military bureaucracy long enough to recognize when official records didn't tell complete stories. "Classified programs. That would explain why. Your technical capabilities seem to exceed your documented training. What kind of classified programs?" The question hung in the air like a trap Elena couldn't avoid stepping into. Acknowledging classified experience would invite further investigation that could expose program details she was oath-bound to protect. Denying it would perpetuate the deception that was becoming increasingly difficult to maintain as her expertise became obvious to observers with sufficient technical background. "Aircraft systems development and testing," Elena replied carefully, providing minimal information while staying technically truthful. "Advanced prototype evaluation under operational conditions." She paused, choosing her next words with precision. That reflected years of practice discussing sensitive information. "Most of the technical details remain classified at levels I'm not authorized to discuss." Wang nodded slowly, clearly processing implications that extended beyond routine personnel management. "Advanced prototype evaluation. That would involve working with experimental aircraft systems, analyzing performance under extreme conditions, troubleshooting problems that standard maintenance procedures couldn't address." Elena confirmed with a slight nod, grateful that Wang's experience allowed her to understand without requiring explicit details that Elena couldn't provide. The supervisor's military background included exposure to classified programs that operated beyond public knowledge, creating context for evaluating Elena's situation. "The harmonic resonance analysis you prepared," Wang continued, pulling Elena's technical report from her desk drawer. "This level of structural engineering knowledge doesn't come from routine maintenance experience. You're talking about frequency characteristics, damping coefficients, electromagnetic interference patterns that most aerospace engineers would struggle to calculate accurately." The assessment was delivered without accusation, more like professional recognition of expertise that deserved acknowledgement regardless of how it had been acquired. Elena felt some tension release as Wang demonstrated understanding of technical complexities involved, rather than suspicion about Elena's qualifications. "I had excellent mentors during my military service," Elena replied diplomatically. "Engineers who understood that effective maintenance required comprehensive knowledge of how aircraft systems interacted under stress conditions. They encouraged learning beyond standard technical manuals." Wang smiled slightly at Elena's careful phrasing, clearly recognizing someone who had been taught to discuss classified experience without revealing operational details. "Excellent mentors who happened to work on advanced prototype evaluation programs. The kind of mentors who don't appear in official personnel records because their own work was classified." Elena nodded again, appreciating Wang's ability to understand context without requiring explicit confirmation of details that remain protected. The supervisor's approach suggested someone who respected security protocols while recognizing that valuable expertise sometimes came from sources that couldn't be fully documented. "Here's my situation, Vasquez," Wang said, leaning forward with the focused attention of someone making important decisions. "I've got a critical aircraft system that's threatening to derail contracts worth hundreds of millions of dollars. Most experienced technicians can't solve the problem using conventional approaches, but you've identified the root cause and proposed solutions that could resolve everything within days." Elena waited, sensing that Wang was building toward a proposal that would change her status at the facility significantly. The supervisor's tone carried the weight of someone who valued results over protocols when national security interests were at stake. "I could spend weeks investigating your background through official channels, trying to verify classified experience that probably isn't documented anywhere accessible to civilian contractors," Wang continued. "Or I could authorize you to implement your harmonic resonance solutions and let technical results demonstrate your capabilities directly." The offer was more generous than Elena had expected, but she recognized the political risks Wang was accepting by endorsing someone whose credentials couldn't be fully verified. "I appreciate your confidence, but implementing structural modifications to classified aircraft systems would require higher authorization than either of us possesses." Wang's expression suggested she had already considered that obstacle and developed solutions Elena hadn't anticipated. "Colonel Sterling spent 2 hours on secure communications yesterday, discussing your analysis with people whose names don't appear on any organizational charts I have access to. This morning I received authorization to provide you with temporary, elevated access credentials." Elena felt surprise and concern in equal measure. Elevated access meant her background was being evaluated by intelligence agencies with capabilities to verify classified service records that civilian contractors couldn't access. Her carefully maintained anonymity was dissolving rapidly as powerful organizations took interest in her technical abilities. "Temporary elevated access for how long?" Elena asked, though she suspected the answer would commit her to involvement beyond what she had intended when she first analyzed the power fluctuation problem. "Long enough to implement your structural modifications and validate their effectiveness," Wang replied. "If your solutions work as projected, your access level could become permanent with corresponding salary adjustments and project responsibilities." She paused, clearly weighing her next words carefully. "If they don't work, both of us will have some difficult questions to answer." Elena understood the implicit bargain being offered. Wang was risking her own career and reputation on Elena's technical judgment, expecting performance that would justify the unprecedented decision to grant classified access based on unverified expertise. The pressure was enormous, but also represented the first opportunity Elena had been given to apply her knowledge officially. "What specific modifications are authorized?" Elena asked, accepting the challenge while wanting to understand its scope clearly. Wang pulled a sealed envelope from her desk drawer, official documents that had arrived through channels Elena couldn't access directly. "Complete structural analysis and modification of engine mounting systems, electronic component repositioning to eliminate harmonic interference, and integration testing to verify performance improvements." Wang read from the authorization documents. "Timeline is 72 hours maximum, with progress reports every 12 hours to oversight personnel whose identities remain classified." Elena felt the familiar surge of anticipation that came with challenging technical problems that pushed her capabilities to their limits. This was the kind of work she had trained for during her military service: critical modifications under extreme time pressure with national security implications riding on successful completion. The next few hours passed in a blur of security processing and credential verification that Elena had experienced before but never expected to encounter in civilian employment. Background investigators with impressive security clearances conducted interviews that probed her military service with precision that confirmed they had access to classified personnel records unavailable to standard contractors. Your previous commanding officers speak very highly of your technical capabilities, mentioned Agent Sarah Martinez during one particularly thorough interview session. Martinez represented agencies that didn't advertise their existence publicly, but whose interest in Elena's background suggested she was being evaluated for possibilities beyond simple aircraft maintenance. Elena provided careful answers that confirmed her service record without revealing specific program details that remained classified, walking the familiar line between honesty and security compliance that had defined much of her military career. The investigators seemed satisfied with responses that demonstrated understanding of classification protocols while acknowledging technical expertise that justified their interest. By late afternoon, Elena found herself standing beside the problematic aircraft with access credentials that permitted detailed examination of systems she hadn't been allowed to approach since her discharge. The sleek stealth prototype represented billions of dollars in research and development, incorporating technologies that wouldn't be acknowledged publicly for decades. Running her hands along the engine mounting points, Elena felt the subtle vibrations that had been causing electronic system interference. Her analysis had been correct. Harmonic resonance at specific frequencies was creating electromagnetic disruption that affected sensitive stealth components. The solution required precise structural modifications that would eliminate resonance frequencies without compromising aircraft performance. Wong appeared beside her as Elena began detailed measurements of mounting configurations and structural load paths. "Feeling confident about your analysis?" the supervisor asked, though her tone suggested more curiosity than doubt about Elena's capabilities. "The physics are straightforward once you identify the resonance frequencies," Elena replied, making calculations that would guide the modification procedures. "The challenge is implementing changes without affecting other systems that depend on current structural configuration." As evening approached, Elena prepared for 3 days of intensive work that would either validate her expertise publicly or expose her as someone whose capabilities exceeded her documented qualifications in ways that couldn't be easily explained. The modified aircraft would either demonstrate American aerospace superiority or become evidence of civilian contractor incompetence that threatened national security programs. Either way, her days of invisible technical support were ending whether she wanted them to or not. Elena arrived at the hangar before dawn, carrying a thermos of coffee and a notebook filled with calculations she had worked on through the night. The stealth aircraft waited under harsh fluorescent lighting, its angular surfaces seeming to absorb illumination rather than reflect it. Her elevated access credentials allowed entry to the secure section where only the most trusted personnel were permitted, a privilege that felt both vindicating and terrifying. The first challenge was more complex than she had anticipated during her initial analysis. The harmonic resonance problem couldn't be solved through simple mounting adjustments because the aircraft's stealth characteristics depended on precise structural geometry. Every modification would affect radar cross-section, properties that had been optimized through years of computational design work. Elena needed to eliminate vibration frequencies while maintaining electromagnetic properties that made the aircraft invisible to enemy detection systems. Working methodically, she began mapping the exact resonance patterns using specialized sensors that measured vibrations at frequencies most technicians couldn't detect. The mounting points were creating sympathetic oscillations that propagated through the airframe structure, generating electromagnetic signatures that interfered with sensitive electronics. Her military experience had taught her to think in terms of systems integration rather than individual components, understanding how changes in one area cascaded through interconnected networks. "Impressive setup you've got here," observed Dr. Mitchell, arriving with Colonel Sterling and 2 other officials Elena didn't recognize. Their security badges indicated clearances above her current level, suggesting that her work was being monitored. by organizations with authority over classified aircraft programs. How long before you can implement the necessary modifications? Elena paused her measurements to address the group that represented significant military and contractor leadership. The structural changes are straightforward, but I need to verify that modifications won't compromise stealth characteristics. Every mounting point adjustment affects electromagnetic properties in ways that could make the aircraft detectable to sophisticated radar systems. Sterling nodded approvingly, clearly understanding the complexity Elena was addressing. That's exactly the kind of systems thinking we need. Too many technicians focus on individual problems without considering broader implications. He gestured toward the aircraft's angular surfaces. This prototype incorporates stealth technology that can't be compromised for the sake of solving electronic interference issues. Elena felt the weight of expectations that extended far beyond routine maintenance work. The officials observing her represented programs with budgets measured in billions of dollars and strategic importance that influenced national defense planning. Success would validate not only her technical capabilities, but also the military's investment in advanced aerospace technology. Failure could delay critical programs for years while alternative solutions were developed. Over the next 6 hours, Elena worked with focused intensity that reminded her of her military service during critical mission preparation. She analyzed structural load paths, calculated electromagnetic field distributions, and designed modifications that would eliminate harmonic resonance without affecting radar absorption properties. The work required understanding material science, structural engineering, and electromagnetic theory at levels most aerospace engineers never achieved. Her modifications were elegant in their simplicity, but sophisticated in their theoretical foundation. By repositioning engine mounts by precise measurements and adding dampening materials with specific electromagnetic properties, she could eliminate destructive frequencies while actually improving the aircraft's stealth characteristics. The solution required materials that existed in classified inventories, but weren't available to standard contractors. Preparing and narrating this type of story took us long efforts and hard work. So if you are enjoying the story, please consider subscribing to our channel. These dampening compounds, Mitchell observed, reviewing Elena's material specifications. They're not in our standard parts catalog. Where would you have encountered these particular electromagnetic absorption characteristics? The question carried undertones of professional curiosity mixed with security concerns about Elena's knowledge of classified materials. Elena chose her words carefully, maintaining security protocols while explaining her technical reasoning. Previous military assignments involved working with experimental materials designed for specific electromagnetic applications. The compounds I'm specifying have properties that would be ideal for this resonance elimination while enhancing overall stealth performance. Sterling exchanged glances with the other officials, clearly processing implications of Elena's familiarity with materials that weren't acknowledged in public documentation. We can acquire these compounds through appropriate channels, he said. Finally, timeline for implementation once materials are available. 18 hours maximum, Elena replied confidently. The structural modifications are precisely calculated, and installation procedures are straightforward for technicians with appropriate security clearances. She had designed the implementation process to be efficient while maintaining the high precision necessary for stealth aircraft applications. As the day progressed, Elena found herself working alongside technicians she hadn't previously encountered, specialists with security badges that indicated involvement in the most classified programs. Their presence confirmed that her modifications were being treated as critical national security work rather than routine maintenance procedures. The atmosphere carried the focused tension she remembered from military operations where mission success depended on technical excellence under extreme pressure. Your calculations are remarkably sophisticated, commented Chief Engineer Patricia Williams, a newly arrived specialist, whose credentials included advanced degrees from institutions that didn't appear in public directories. Williams had spent the afternoon reviewing Elena's technical documentation with the detailed attention of someone evaluating work that would influence major program decisions. Elena acknowledged the compliment while continuing her structural analysis, measuring mounting points with precision that ensured modifications would achieve intended results without creating new problems. The physics are complex but manageable once you understand how different systems interact under operational stress conditions. Williams nodded thoughtfully, clearly recognizing someone whose technical understanding exceeded standard contractor capabilities. Your approach integrates electromagnetic theory with structural engineering in ways that suggest extensive experience with classified aircraft systems. That level of interdisciplinary expertise usually takes years to develop. The observation was delivered as professional recognition rather than suspicious questioning, but Elena sensed that her background was being evaluated by people with access to information she couldn't discuss openly. Her military service records were apparently more accessible to current investigators than she had realized when accepting her civilian position. Late afternoon brought the arrival of specialized materials. Elena had requested compounds with electromagnetic properties that existed only in classified inventories. Their availability confirmed that her modifications had been approved at levels far above local facility authority, involving decision-makers whose influence extended throughout military aerospace programs. Working with materials she hadn't handled since her active duty service, Elena began implementing structural changes that would transform the problematic aircraft into a demonstration of American technological superiority. The dampening compounds required precise application techniques that she had learned during classified programs, knowledge that officially didn't exist in civilian contractor databases. Fascinating application method, observed Williams, watching Elena work with materials that most contractors had never seen. Those installation techniques aren't in standard technical manuals. Where would civilian maintenance personnel learn such specialized procedures? Elena paused her work to address the question that was becoming increasingly difficult to answer without revealing classified experience. Military training sometimes included exposure to experimental techniques that weren't widely documented. Experienced technicians learned to adapt methods based on operational requirements rather than following standardized procedures exclusively. The explanation was technically accurate while avoiding specific details about programs that remained classified years after her discharge. Williams seemed satisfied with the response, though her expression suggested continued curiosity about Elena's background and capabilities. As evening approaches, Elena's modifications were taking shape with precision that impressed even the most experienced observers. The structural changes eliminated harmonic resonance frequencies while actually improving the aircraft's stealth characteristics through optimized electromagnetic absorption. Her solution exceeded requirements while demonstrating technical innovation that could be applied to future aircraft programs. Outstanding work, Vasquez, Sterling commented during his final inspection of the day. Your modifications not only solve the immediate problem, but create performance improvements that could benefit entire fleet applications. He paused, clearly considering implications that extended beyond current aircraft issues. This kind of systems integration thinking is exactly what advanced programs need. Elena felt satisfaction that came from applying expertise she had developed during years of classified service to problems that challenged conventional engineering approaches. The work reminded her why she had chosen aerospace technology as her career focus, the intellectual challenges of pushing technological boundaries while contributing to national defense capabilities. But as she secured her tools and prepared to leave the hangar, Elena also recognized that her carefully maintained anonymity was ending permanently. Tomorrow would bring testing that would either validate her modifications publicly or expose them as unsuccessful attempts to solve problems beyond her actual capabilities. Either outcome would change her status at the facility and within military contractor communities that valued proven performance above all other qualifications. The stealth aircraft waited under security lighting, its modified structure representing 3 days of intensive work that would determine Elena's future in aerospace technology. Her invisible years of contribution were ending, replaced by visible demonstration of capabilities that would either open new opportunities or create scrutiny she had spent her civilian career trying to avoid. The testing phase began at 060 hours, with an array of diagnostic equipment that Elena had never seen deployed for routine maintenance validation. Pentagon officials occupied an observation area that had been hastily constructed overnight, while defense contractors with billion-dollar program interests monitored every aspect of the modified aircraft's performance through real-time telemetry systems that fed directly to Washington. Decision-makers. Elena stood beside the aircraft as senior test engineers conducted pre-flight systems checks, her stomach tight with anxiety that she couldn't show to the dozens of observers whose careers and contracts depended on her modifications proving successful. The stealth prototype represented the pinnacle of American aerospace technology, incorporating innovations that foreign intelligence services would kill to understand, and she had altered its fundamental structural characteristics based on analysis that contradicted conventional engineering wisdom. All electronic systems showing nominal parameters, announced Chief Test Engineer Robert Kim, his voice carrying across the hangar through speakers that allowed everyone present to monitor progress. Kim was a legend within military aviation circles, responsible for validating experimental aircraft that pushed the boundaries of physics and material science. His presence indicated that Elena's modifications were being treated with the seriousness reserved for technologies that could determine America's military superiority for decades. The first phase involved static testing with the aircraft's engines running at various power settings, while sophisticated sensors measured electromagnetic signatures, structural vibrations, and electronic system performance. Elena watched displays that showed frequency analysis in real time, praying that her calculations had been accurate and that the harmonic resonance problems she had identified were truly eliminated by her structural modifications. Power fluctuations showing significant improvement, reported systems specialist Amanda Torres, monitoring electronic warfare systems that had been plagued by the mysterious instabilities. Electronic component performance is stable across all frequency ranges, with no indication of the interference patterns that caused previous system failures. Elena felt cautious optimism as preliminary results confirmed her theoretical analysis, but she knew that real validation would come during flight testing when the aircraft experienced operational stresses that couldn't be replicated in static conditions. The Pentagon observers were taking detailed notes, clearly preparing reports that would influence program funding decisions and potentially affect Elena's future security clearance status. Colonel Sterling approached Elena's position with an expression that suggested both satisfaction with current results and awareness that more challenging tests lay ahead. Static performance looks excellent, Vasquez. Your harmonic analysis appears to have been completely accurate. He paused, studying readouts that showed system performance exceeding baseline specifications. The question now is whether these improvements will hold up under flight conditions. Elena nodded, understanding that her modifications would face their ultimate test when the aircraft experienced the complex stress patterns of actual flight operations. Military aircraft operated in environments that subjected every component to forces that desktop calculations couldn't fully predict, and stealth systems were particularly sensitive to structural changes that affected their electromagnetic properties. Flight test authorization has been confirmed, announced Dr. Mitchell over the facility's communication system. Test pilot Major Lisa Rodriguez will conduct a comprehensive evaluation profile that includes all operational flight regimes. Rodriguez was renowned for her ability to evaluate experimental aircraft under conditions that revealed problems other pilots might miss, making her assessment particularly valuable for validating Elena's modifications. The next 2 hours passed with mechanical preparation and safety checks that Elena recognized from her military experience with classified aircraft programs. Every system was verified multiple times by different technicians, creating redundant confirmation that the modified aircraft met safety standards for flight operations. The thoroughness reflected both professional competence and awareness that failure during flight testing could result in catastrophic loss of irreplaceable prototype aircraft. Elena found herself assigned to the Mission Control Center where she could monitor telemetry data during flight operations, a privilege typically reserved for senior engineers with extensive test experience. Her temporary elevated access credentials allowed her to observe classified aircraft performance data that civilian contractors rarely saw, information that could validate or condemn her technical analysis definitively. Interesting flight profile. They've planned, observed Dr. Williams, reviewing test procedures that would evaluate the aircraft under every conceivable operational condition. High-speed maneuvers, electronic warfare system activation, stealth mode verification, and extended duration operations. If your modifications work under these conditions, they'll work under any conditions the aircraft might encounter operationally. Elena studied the test profile with growing appreciation for its comprehensiveness and mounting anxiety about its rigor. Major Rodriguez would push the aircraft through performance envelopes that would stress every system she had modified, revealing weaknesses that static testing couldn't detect. The stealth prototype would either demonstrate unprecedented capability or experience failures that could end Elena's aerospace career permanently. Flight operations began with standard takeoff procedures that immediately subjected Elena's structural modifications to dynamic loads significantly different from static conditions. She watched telemetry displays that showed engine performance, structural stress patterns, and electronic system stability in real time, searching for any indication that her harmonic resonance solutions were failing under operational conditions. All systems nominal through initial climb, reported Major Rodriguez, her voice calm and professional despite piloting an aircraft that incorporated experimental modifications of unknown reliability. Electronic warfare systems are responding normally, with no indication of the interference patterns reported in previous flight tests. Elena felt her first surge of genuine optimism as flight data confirmed that her modifications were performing as calculated under real operational stresses. The aircraft was demonstrating electronic system stability that had been impossible to achieve before her structural changes, validating her analysis of harmonic resonance problems that conventional troubleshooting had failed to identify. Testing profile intensified as Major Rodriguez began high-speed maneuvers that subjected the aircraft to extreme G-forces and rapid attitude changes. Elena watched structural stress indicators with focused attention, knowing that her engine mount modifications would face their greatest challenge during aggressive flight operations that pushed airframe components to their design limits. Pulling 6 Gs in sustained turn, Rodriguez reported, executing maneuvers that would reveal any weakness in Elena's structural modifications immediately. All systems remaining stable, no unusual vibrations or electronic anomalies detected. Her tone carried the confidence of a test pilot who could detect problems that instruments might miss, making her positive assessment particularly meaningful for validation purposes. Pentagon observers were clearly impressed by performance data that exceeded their expectations for modified experimental aircraft. Elena overheard conversations about extending the test profile to include operational conditions that hadn't been originally planned, suggesting that her modifications were performing so well that officials wanted to evaluate their full potential. rather than simply confirming basic functionality. Electronic warfare systems are performing 40% better than baseline specifications, announced systems specialist Therese, monitoring classified capabilities that Elena knew represented American technological advantages over potential enemies. The structural modifications have actually improved stealth performance while eliminating the interference problems completely. Elena felt professional satisfaction that transcended personal vindication, knowing that her work was contributing to national defense capabilities that could protect American lives in future conflicts. The modified aircraft was demonstrating performance improvements that would influence military procurement decisions and potentially enhance America's strategic advantages over adversaries who were developing their own advanced aerospace technologies. Most challenging phase began when Major Rodriguez activated full electronic warfare systems while executing high-speed, stealth penetration profiles that simulated operational missions in hostile airspace. Elena's modifications would face simultaneous stresses from extreme flight conditions and maximum electronic system operation, creating the ultimate test of whether her harmonic resonance solutions could maintain effectiveness under combat realistic conditions. Stealth systems operating at maximum efficiency, Rodriguez reported. Flying profiles that would make the aircraft invisible to sophisticated enemy radar while maintaining full electronic warfare capability. No degradation in any system performance. Excellent aircraft handling characteristics throughout the flight envelope. Elena watched classified performance data that showed her modifications had created an aircraft capability that exceeded original design specifications by significant margins. The Pentagon observers were making phone calls to officials whose identities remained classified, clearly reporting success that would influence program decisions at the highest levels of government. As the flight test phase approached completion, Elena realized that her anonymous years in aerospace technology were ending permanently. The modified aircraft was performing so well that her technical capabilities would be recognized officially, opening opportunities she had never expected while creating scrutiny she had spent years avoiding. Outstanding results, Vasquez, Colonel Sterling said, reviewing telemetry data that documented unprecedented aircraft performance improvements. Your modifications haven't just solved the original problem. They've created capabilities that could revolutionize how we approach stealth aircraft design. Elena nodded acknowledgement while processing the implications of success that exceeded her own expectations. Tomorrow would bring decisions about her future role in programs that remained classified at levels she couldn't discuss, but whose importance to national security was becoming undeniably clear. Major Rodriguez brought the aircraft to a perfect landing, completing flight operations that had validated Elena's expertise beyond any doubt while demonstrating American aerospace superiority that would influence international power balances for decades to come. The debriefing session convened 30 minutes after Major Rodriguez completed her landing, with Pentagon officials, defense contractors, and facility leadership gathering in the secure conference room that had been hastily reconfigured to accommodate the unprecedented success of Elena's modifications. The atmosphere carried an electric tension that Elena recognized from her military service during critical mission evaluations, where technical performance data would determine strategic decisions affecting national security for years to come. Flight test results exceed all projected parameters, announced Chief Test Engineer Kim, presenting data on multiple screens that showed aircraft performance across every measured category. Electronic system stability improved by 43%, stealth characteristics enhanced by 37%, and structural integrity maintained throughout the entire operational envelope with 0 anomalies detected. Elena sat quietly at the back of the room, still processing the magnitude of what her modifications had achieved. The stealth prototype had not only overcome its original problems but had evolved into a demonstration of American technological capabilities that foreign intelligence services would spend billions attempting to understand or counter. Her harmonic resonance analysis, initially dismissed as overreach by a maintenance technician, had produced breakthrough improvements that seasoned aerospace engineers hadn't thought possible. Colonel Sterling stood to address the assembled group, his weathered face bearing the satisfaction of someone who had witnessed American military superiority validated through superior engineering and innovative thinking. Ladies and gentlemen, what we've observed today represents a paradigm shift in how we approach stealth aircraft development. The modifications implemented by Elena Vasquez have created capabilities that redefine what's possible with existing technology. The formal recognition felt surreal to Elena, who had spent years ensuring that other people received credit for innovations she had developed during classified programs. Now she was being acknowledged publicly for work that bore her name exclusively, creating a permanent record of technical achievement that would follow her throughout any future aerospace career she might pursue. Dr. Mitchell approached Elena after the formal presentations concluded, carrying documents that suggested important decisions were being made regarding Elena's future involvement in classified programs. The Pentagon wants to discuss long-term assignment options with you, Vasquez. Your technical capabilities have attracted attention from program directors who oversee some of the military's most advanced aerospace projects. Elena felt the familiar mixture of professional excitement and personal apprehension that came with opportunities involving classified technology development. Her military experience had taught her that exceptional performance often led to assignments with increasing responsibility and corresponding security scrutiny that could complicate civilian relationships and personal freedom. What kind of long-term assignments? Elena asked, though she suspected the answer would involve projects that couldn't be discussed outside secure facilities with people who possessed appropriate clearances. Mitchell's expression suggested opportunities that would utilize Elena's expertise fully while demanding absolute discretion about technical details that remained classified at the highest levels. Advanced propulsion research, next-generation stealth technology integration, and materials development programs that won't be acknowledged publicly for decades, Mitchell replied, her voice carrying the weight of someone who understood both the professional opportunities and personal sacrifices involved in such assignments. The kind of work that defines American technological superiority, but requires complete dedication to security protocols. Elena nodded, understanding that acceptance would mean returning to the classified world she had left behind when her military service ended. The anonymous civilian career she had built would be replaced by official recognition and resources that could accelerate aerospace innovation beyond anything possible in commercial development programs, but at the cost of personal privacy and freedom that she had grown to appreciate. The afternoon brought a parade of officials, whose names didn't appear on any public organizational charts, but whose authority over classified programs was absolute. Elena found herself describing her technical background, educational experience, and career objectives to investigators who clearly possessed detailed knowledge of her military service record and classified project involvement that she couldn't discuss openly. Your previous commanding officers speak exceptionally highly of your technical capabilities and professional discretion, mentioned Agent Patricia Davis during one particularly comprehensive interview session. Davis represented organizations that operated beyond public oversight, but whose interest in Elena's background confirmed that her modifications had attracted attention from intelligence agencies responsible for maintaining American technological advantages. Elena provided careful responses that acknowledged her military experience without violating security oaths that remained binding years after her discharge, walking the familiar line between honesty and classification. Compliance that had defined much of her previous career. The investigators seemed satisfied with answers that demonstrated understanding of security requirements while confirming technical expertise that justified their interest. By late afternoon, the implications of Elena's success were becoming clear. Through conversations she overheard among senior officials who were planning program modifications based on her demonstrated capabilities. Defense contractors were discussing contract amendments that would incorporate her techniques into fleet-wide applications, while Pentagon representatives were authorizing research funding that would explore the broader applications of her harmonic resonance analysis methods. This could revolutionize how we approach structural engineering for stealth applications. Elena heard Dr. Williams tell Colonel Sterling during a discussion about program expansion possibilities. Her integration of electromagnetic theory with mechanical engineering opens possibilities we hadn't considered for existing aircraft upgrades and future design projects. Elena felt the professional satisfaction that came from knowing her work would influence American aerospace development for decades, but also recognized that her anonymous civilian existence was ending whether she wanted it to or not. The technical knowledge she had carefully concealed was now documented officially, creating opportunities and obligations that would define her future career path completely. The most significant conversation occurred when Colonel Sterling approached Elena privately as the facility prepared to secure classified materials for the evening. His expression carried the serious attention of someone making offers that could transform careers while demanding absolute commitment to national service priorities. "Elena, I'm authorized to offer you immediate reinstatement to active duty with rank advancement to major, assignment to the Advanced Aerospace Research Division, with unlimited research budget and access to technologies that civilian contractors never see," Sterling said, his words carrying the weight of opportunities that most aerospace engineers could only dream about receiving. Elena felt the pull of work that would utilize her capabilities fully while contributing to projects that could determine America's strategic advantages for generations. The offer represented validation of expertise she had developed through years of dedication and study, but also meant abandoning the personal freedom she had earned through military service and civilian career development. What would be the specific research focus? Elena asked, though she suspected the answer would involve projects that pushed the boundaries of physics and material science beyond anything currently acknowledged in public aerospace development programs, hypersonic propulsion systems, advanced stealth technology that makes current capabilities obsolete, and materials research that could enable aircraft performance levels that foreign adversaries couldn't match or counter. Sterling replied, describing work that would place Elena at the forefront of American technological development while requiring absolute security compliance. Elena requested time to consider the offer, understanding that acceptance would change her life fundamentally, while potentially contributing to national defense capabilities that could protect American interests in an increasingly complex global security environment. The decision would determine whether she continued building on civilian aerospace achievements or returned to classified programs where her contributions would remain invisible to public recognition. As evening approached, Elena found herself alone in the hangar with the modified aircraft that had validated her expertise and created opportunities she had never anticipated when accepting routine maintenance employment. The sleek prototype represented the culmination of years spent developing technical knowledge while remaining invisible to official recognition, but also symbolized possibilities for future contributions that could exceed anything she had previously achieved. The stealth aircraft's angular surfaces reflected hangar lighting in patterns that seemed to shift and change as Elena walked around its perimeter, examining structural modifications that had transformed problematic equipment into a demonstration of American technological superiority. Her work had proven that innovation often came from unexpected sources, and that expertise couldn't be confined by conventional assumptions about qualifications or backgrounds, but success had also exposed Elena to scrutiny and opportunities that would require choosing between personal privacy and professional achievement, between anonymous civilian career development and official recognition, within classified programs that could utilize her capabilities fully while demanding absolute dedication to national service priorities. The decision would determine not only her individual future, but potentially influence American aerospace development in ways that could affect global power balances. For decades to come, Elena spent the night walking the desert perimeter of Edwards Air Force Base, wrestling with the decision that would define the remainder of her career and potentially her entire life. The offer from Colonel Sterling represented everything she had worked toward during her military service: official recognition, unlimited resources, and the opportunity to push aerospace technology beyond current limitations. Yet accepting meant abandoning the personal autonomy she had fought to establish during her civilian career transition. The morning brought unexpected complications that made her decision more urgent than she had anticipated. Elena arrived at the maintenance facility to find activity levels that suggested major program developments were accelerating based on her previous day's success. Additional security personnel had appeared overnight, and classified equipment was being installed that she recognized from her military experience with the most sensitive aerospace programs. "Vasquez, we need to talk immediately," Wang announced, approaching Elena's workstation with documents that bore security classifications above Elena's current clearance level. "The Pentagon has accelerated the timeline for several major decisions based on yesterday's flight test results. Your technical modifications have created opportunities that weren't expected for another 5 years." Elena followed Wang to the secure conference room where Colonel Sterling waited with officials she hadn't previously encountered. Their security badges indicated involvement in programs that operated beyond public oversight, suggesting that her harmonic resonance solutions had attracted attention from organizations responsible for America's most classified technological advantages. "Elena, your modifications have produced results that exceed our most optimistic projections," Sterling began, gesturing toward classified displays that showed performance data from multiple aircraft systems. "Defense Department leadership wants to implement your techniques across the entire stealth aircraft fleet, starting with immediate deployment to operational squadrons." The implications were staggering. Elena's structural engineering solutions, developed initially to solve problems with a single prototype, were being adopted as standard procedures for America's most advanced military aircraft. Her techniques would influence hundreds of aircraft, worth billions of dollars, affecting operational capabilities that could determine outcomes of future conflicts. Fleet-wide implementation would require extensive training programs for maintenance personnel, who currently lack the theoretical background to understand harmonic resonance analysis, Elena observed, recognizing technical challenges that accompanied rapid program expansion. "The electromagnetic theory involved isn't covered in standard aerospace maintenance curricula." Sterling nodded approvingly, clearly appreciating Elena's awareness of implementation complexities that less experienced engineers might overlook. "That's exactly why we need you to develop comprehensive training protocols and serve as primary technical advisor for the entire implementation program. Your expertise would be essential for ensuring consistent results across multiple facilities and aircraft variants." Elena felt the weight of responsibility that came with technical innovations that could affect American military capabilities for decades. Her individual contributions would be multiplied across entire aircraft fleets, creating strategic advantages that foreign adversaries would struggle to understand or counter. The professional satisfaction was immense, but so was the pressure to maintain performance standards that could influence national security directly. Dr. Williams entered the conference room with additional officials whose presence indicated that Elena's situation had attracted attention from the highest levels of military leadership. Their expressions carried the focused intensity of people making decisions with implications that extended far beyond individual career advancement or program funding considerations. Elena, I'm authorized to present you with several options that reflect the strategic importance of your technical capabilities, Williams announced, opening classified folders that contained offers Elena suspected would transform her professional life completely. Each represents different approaches to utilizing your expertise while addressing national defense priorities that have become urgent based on international developments. The first option involved immediate assignment to the Pentagon's Advanced Research Projects Division with unlimited budget authority for developing next-generation stealth technologies that would maintain American superiority over emerging foreign capabilities. Elena would lead teams of the military's most talented engineers while having access to experimental technologies that civilian contractors never encountered. The second possibility was assignment to a classified facility where Elena would work exclusively on hypersonic aircraft development, creating propulsion and stealth systems that could enable military operations at speeds and altitudes that current aircraft couldn't achieve. The work would push the boundaries of material science and aerodynamics beyond anything currently acknowledged in public aerospace programs. The third alternative involved establishing Elena as the military's primary consultant for electromagnetic stealth technology, traveling between facilities to solve problems that challenged conventional engineering approaches while developing training programs that would disseminate her techniques throughout the aerospace community. This option would provide maximum flexibility while ensuring her expertise influenced the broadest range of military aircraft programs. Elena studied the classified documents that outlined each possibility, recognizing opportunities that most aerospace engineers would consider career-defining achievements worthy of lifelong dedication. Each option offered resources and authority that could accelerate American technological development while providing personal recognition for contributions that had previously remained invisible. There's also a fourth possibility, Sterling added. Quietly, producing documents that bore security classifications Elena had rarely encountered even during her military service. Complete civilian contractor status with security clearances that would allow independent research and development under Pentagon oversight. You would maintain personal autonomy while contributing to classified programs through consultation, rather than direct employment. This final option intrigued Elena most significantly because it would allow continued civilian career development while providing opportunities to contribute technical expertise to projects that could influence American strategic capabilities. She could maintain the personal freedom she had fought to establish while ensuring her knowledge benefited national defense programs that desperately needed innovative approaches to emerging technological challenges. The decision process was complicated. By growing awareness that foreign intelligence services were actively monitoring American aerospace developments, seeking to identify personnel whose technical capabilities could threaten their own military advantages. Elena's public success with stealth aircraft modifications had potentially exposed her to targeting by adversaries who would benefit from compromising or eliminating American technological expertise. Security considerations are significant regardless of which option you choose, Agent Davis mentioned during a private consultation that afternoon. Your demonstrated capabilities with classified stealth technology make you a high-value target for foreign intelligence operations. Any assignment would require comprehensive security protocols that could affect personal relationships and lifestyle choices. Elena nodded, understanding that exceptional technical expertise in classified fields came with personal risks that extended beyond professional responsibilities. Her knowledge of American stealth capabilities made her valuable to enemies who would use any available methods to acquire information that could compromise national defense advantages. The afternoon brought additional pressure from defense contractors who recognized that Elena's techniques could provide competitive advantages, worth billions of dollars in future military procurement contracts. Representatives from major aerospace corporations made increasingly aggressive offers designed to secure Elena's expertise for commercial applications that could revolutionize civilian aircraft development while generating enormous profits. Your harmonic resonance analysis could transform commercial aviation as significantly as military applications, suggested Marcus Thompson, representing a consortium of defense contractors with combined annual revenues exceeding $50 billion. We're prepared to offer compensation packages that would make you independently wealthy, while providing resources for research that could benefit both civilian and military aerospace development. Elena listened politely to offers that would provide financial security beyond anything she had previously imagined, but recognized that commercial applications of her knowledge could potentially compromise the military advantages that her techniques provided to American defense capabilities. The ethical implications of sharing classified aerospace knowledge with commercial entities were complex and potentially problematic from national security perspectives. As evening approached, Elena found herself facing the most significant career decision of her life, with implications that extended far beyond personal advancement or financial considerations. Each option would determine not only her individual future, but potentially influence American aerospace development in ways that could affect global power balances for generations. The modified aircraft waited in the hangar as a symbol of what individual expertise could achieve when properly applied to challenging technical problems, but also as evidence that exceptional performance created opportunities and obligations that could define entire careers through their strategic importance to national defense priorities. Elena's decision would determine whether American technological superiority continued advancing through innovative approaches that challenged conventional engineering limitations, or whether her expertise would be diverted toward applications that might compromise the military advantages her knowledge could provide to national defense programs. During an era of increasing international competition, Elena's decision crystallized. During a pre-dawn walk across the desert where she had first arrived weeks earlier as an anonymous maintenance technician seeking civilian employment, the vast expanse of sand and scrub brush provided perspective on choices that would determine not only her individual future, but potentially influence American aerospace capabilities for decades. She had spent her entire adult life developing expertise that could serve national defense, and walking away from that mission now felt like betraying everything she had worked to achieve. Returning to the facility at sunrise, Elena found Colonel Sterling in the secure conference room, reviewing classified reports that suggested international developments were accelerating the timeline for American stealth technology deployment. His expression carried the focused intensity of someone managing programs where delays could compromise strategic advantages that took decades to develop. "I've made my decision," Elena announced without preamble, settling into the chair across from Sterling with the calm determination that had defined her approach to complex technical challenges throughout her career. "I'll accept the civilian contractor position with enhanced security clearances. I want to contribute to national defense programs while maintaining the flexibility to pursue research directions that might not fit traditional military development timelines." Sterling nodded approvingly, clearly pleased that Elena had chosen the option that would provide maximum strategic benefit while respecting her desire for professional autonomy. "That's the choice I was hoping you'd make. Your expertise is too valuable to confine within rigid organizational structures, but too important to national security to waste on purely commercial applications." The paperwork associated with Elena's new status required most of the morning, involving security protocols that granted her access to classified programs across multiple agencies while maintaining her civilian independence. She would report directly to Pentagon oversight committees that manage the military's most sensitive aerospace projects, but with authority to pursue research directions that conventional military hierarchies might resist or delay. Elena's first official assignment involved developing comprehensive training protocols that would allow military maintenance personnel to implement her harmonic resonance analysis techniques across the entire stealth aircraft fleet. The challenge was translating theoretical knowledge that had taken her years to master into practical procedures that technicians with standard military training could apply consistently and effectively, working in a newly established, secure laboratory facility. Elena began creating documentation that would democratize expertise previously available only to engineers with advanced theoretical backgrounds. Her training materials needed to explain complex electromagnetic theory in terms that experienced mechanics could understand and apply without compromising the precision necessary for stealth aircraft applications. "This is remarkable work," observed Dr. Sarah Chun, a Pentagon-assigned technical reviewer who possessed multiple advanced degrees in aerospace engineering and material science. Chun had been tasked with evaluating Elena's training protocols to ensure they met military standards for technical accuracy and operational practicality. "You're essentially creating a new field of applied electromagnetic maintenance that doesn't exist in current military curricula." Elena appreciated Chun's recognition of the broader implications of her work, which extended beyond solving immediate aircraft problems to establish foundational knowledge that could influence aerospace maintenance for generations. Her training protocols would teach thousands of military technicians to think about aircraft systems in ways that conventional education had never addressed. The development process was complicated by security requirements that prevented Elena from revealing classified details about stealth technology, while still providing sufficient technical depth to enable effective maintenance procedures. She needed to explain electromagnetic principles without disclosing specific aircraft capabilities that foreign intelligence services would find valuable for developing countermeasures. "The classification balance is challenging," Elena admitted during one of her regular progress reviews with Pentagon oversight personnel. "Maintenance technicians need enough theoretical understanding to apply the techniques correctly, but too much detail could compromise operational security if training materials were ever compromised by foreign intelligence operations." Colonel Sterling, who had become Elena's primary liaison with Pentagon leadership, understood the complexity of balancing technical education with security requirements. "That's exactly why this assignment requires someone with your combination of theoretical expertise and classified program experience. Standard aerospace engineers lack the security awareness necessary to navigate these classification boundaries effectively." Elena's work attracted attention from international partners who recognized that American stealth technology advances could influence global military balances significantly. Representatives from allied nations requested access to her training protocols, hoping to improve their own aircraft maintenance capabilities while maintaining interoperability with American systems during joint operations. "The British and Australians are particularly interested in your electromagnetic analysis techniques," mentioned Agent Davis during one of their regular security briefings. "Their stealth aircraft programs could benefit significantly from your methods, but sharing requires careful consideration of technology transfer implications and long-term strategic relationships." Elena found herself consulting on technology sharing decisions that affected international partnerships while potentially influencing foreign military capabilities in ways that could impact American strategic advantages. Her technical innovations had become diplomatic tools that required balancing alliance relationships against national security interests. The most challenging aspect of Elena's new role involved troubleshooting problems with operational aircraft that were experiencing issues similar to those she had solved with the original prototype. Military bases worldwide were reporting electromagnetic interference problems that suggested her modifications needed adaptation for different aircraft variants and operational environments. Working through secure communication systems, Elena provided remote technical support to maintenance teams at classified locations, whose identities remained protected, but whose aircraft problems required her specialized expertise. Each consultation involved analyzing electromagnetic conditions and structural configurations through data transmissions rather than direct examination, creating diagnostic challenges that pushed her analytical capabilities to new limits. Aircraft stationed in maritime environments are showing different resonance patterns than desert-based systems. Elena reported during one Pentagon briefing that included representatives from multiple military branches. Salt air corrosion affects electromagnetic properties in ways that require modification of standard dampening procedures. These performance evaluations describe capabilities that are being completely wasted in her current assignment. Williams continued, spreading documents across Colonel Hayes's desk that told a story of institutional blindness. "We have the most qualified precision shooter on this base cleaning weapons, while lesser trained personnel struggle with advanced marksmanship instruction." The classified after-action reports from Elena's deployment in Kandahar province provided detailed accounts of her tactical contributions that had been omitted from her official personnel file. Multiple mission reports documented her ability to provide accurate intelligence, eliminate high-value targets, and prevent friendly fire casualties through superior marksmanship and tactical awareness. Colonel Hayes reviewed the documentation with growing recognition that Elena's reassignment had been based on incomplete information and institutional assumptions that ignored her demonstrated capabilities. The court-martial proceedings had focused narrowly on her refusal to follow orders, while completely overlooking the tactical accuracy of her assessment that had prevented civilian casualties. Master Sergeant Williams, this documentation suggests that Sergeant Vasquez was court-martialed for making the correct tactical decision under combat conditions, Colonel Hayes observed, studying reports that praised Elena's judgment and tactical competence. Her refusal to fire appears to have been based on accurate intelligence that contradicted flawed operational planning. The investigation team was expanded to include personnel with security clearances sufficient for reviewing classified materials related to Elena's previous assignments and the circumstances surrounding her reassignment to Fort Henderson. The broader inquiry revealed institutional failures that extended beyond simple personnel management into questions of military justice and operational effectiveness. Elena's original court-martial proceedings were re-examined by legal specialists, who recognized that her case had been adjudicated under political pressure rather than objective evaluation of tactical decision-making under combat conditions. The plea bargain that had resolved her case appeared to have been designed to protect higher-ranking officers rather than ensure appropriate justice for subordinate personnel. The evidence suggests that Sergeant Vasquez was punished for demonstrating superior tactical judgment that embarrassed field-grade officers who had made poor decisions based on inadequate intelligence, reported Major Jennifer Costa, the legal officer assigned to review Elena's case files. Her actions probably prevented an international incident while saving civilian lives. The precision supply delivery that had initiated the current investigation was recontextualized as evidence of Elena's exceptional capabilities rather than unauthorized weapons usage requiring disciplinary action. Her technical achievement under extreme conditions demonstrated exactly the kind of competence that military institutions should recognize and utilize rather than suppress through bureaucratic restrictions. Colonel Hayes authorized a comprehensive review of Elena's personnel file and current assignment appropriateness, recognizing that institutional credibility required acknowledgement of administrative errors that had wasted exceptional talent for 18 months. The review process would examine whether Elena's skills could be properly utilized within existing organizational structures. The rescued climbers provided testimonial evidence that emphasized the life-saving Impact of Elena's unauthorized actions during the emergency operation. Their statements described the precision supply delivery as exceptional military competence that had enabled their survival under conditions that had defeated conventional rescue methods. The emergency supplies arrived exactly where we needed them with timing that prevented fatal hypothermia, testified David Martinez, one of the rescued climbers, during an official debriefing. Whoever accomplished that delivery demonstrated skill that exceeded anything we'd expected from military rescue operations. The investigation's focus shifted from punitive measures to institutional learning opportunities that could prevent similar waste of personnel capabilities in future assignments. Elena's case became a study in how bureaucratic processes could systematically underutilize exceptional talent while maintaining technical compliance with regulatory requirements. Fort Henderson's command structure faced questions about oversight. Mechanisms that had allowed exceptional personnel to languish in inappropriate assignments while operational units struggled with capability gaps that could have been filled through proper personnel utilization. The case highlighted institutional blindness that prioritized administrative convenience over mission effectiveness. Elena's technical expertise in ballistics, marksmanship, and tactical operations represented capabilities that were desperately needed by the Advanced Marksmanship Unit and other specialized training programs at Fort Henderson. Her current assignment in basic weapons maintenance constituted organizational malpractice that wasted taxpayer investment in advanced military training. The rescue operation's success provided irrefutable evidence of Elena's exceptional capabilities under extreme conditions, demonstrating competence that exceeded the performance of supposedly elite personnel who had been unable to contribute meaningfully to the emergency response. Her unauthorized actions had accomplished what authorized personnel could not achieve through conventional methods. Colonel Hayes faced institutional pressure to acknowledge administrative failures that had created Elena's situation while developing corrective measures that could restore appropriate utilization of her exceptional capabilities. The case required balancing military discipline with recognition that punishing success would discourage the kind of initiative that saves lives during emergency operations. The investigation's conclusions emphasized that Elena's actions during the rescue operation represented exactly the kind of competence and moral courage that military institutions should cultivate rather than suppress through bureaucratic punishment. Her willingness to exceed assigned duties to save lives demonstrated leadership qualities that deserved recognition rather than disciplinary action. Master Sergeant Williams recommended immediate reassignment of Elena to positions that could properly utilize her advanced capabilities, arguing that continued waste of her exceptional skills would constitute institutional failure that damaged operational effectiveness while demoralizing exceptional personnel throughout the command structure. The formal investigation report concluded that Elena's unauthorized actions had been justified by emergency circumstances and had demonstrated capabilities that had been systematically underutilized through inappropriate personnel assignment policies. The report recommended comprehensive review of personnel utilization practices to prevent similar institutional failures in future operations. The formal hearing convened at 0800 hours on a Thursday morning that would transform Elena's career from institutional exile to recognition of exceptional capability. Colonel Hayes presided over proceedings that had evolved from disciplinary inquiry into personnel reconsideration, with Master Sergeant Williams presenting evidence that challenged fundamental assumptions about Elena's qualifications and assignment appropriateness. This hearing will determine the appropriate response to recent events involving Sergeant Vasquez and the circumstances surrounding her current assignment. Colonel Hayes announced to the assembled panel of senior officers who would evaluate Elena's case. Evidence has emerged that requires comprehensive review of previous personnel decisions and their continuing validity. Elena sat in dress uniform at the respondent's table, flanked by Captain Sarah Mitchell, The defense attorney who had finally received access to classified materials that painted a dramatically different picture of Elena's combat record and the circumstances. General Morrison leaned forward with obvious interest, recognizing Elena's proposal as potentially game-changing innovation that could restore American stealth advantages permanently rather than temporarily. What timeline would be required for developing operational adaptive stealth capabilities? Elena's calculations suggested that intensive development programs could produce prototype systems within 3 years. But full fleet implementation would require additional time for testing and production scaling that made widespread deployment realistic within 7 years maximum. The timeline was aggressive but achievable with unlimited funding and priority. Access to the military's most advanced research facilities. The Chinese and Russians won't remain static during our development period, Sterling warned, highlighting the competitive pressure that would accelerate foreign countermeasure development. While American adaptive stealth programs were still experimental, we need solutions that anticipate their likely advances rather than simply responding to current capabilities. Elena nodded, understanding that her adaptive stealth concept needed sufficient technological sophistication to maintain American advantages even against foreign systems that wouldn't be deployed for another decade. The development program would require anticipating technological evolution across multiple disciplines while creating capabilities that could adapt to threats that didn't yet exist. The Pentagon authorized Elena's adaptive stealth research program that afternoon, providing unlimited budget authority and access to classified technologies that civilian contractors rarely encountered. Her work would integrate artificial intelligence, advanced material science, and electromagnetic theory into systems that could redefine aerospace capabilities fundamentally. Elena's new laboratory facility occupied an entire underground level of a classified research complex, equipped with electromagnetic testing chambers and computational resources that exceeded those available to most universities and commercial aerospace companies combined. Her research team included specialists recruited from programs so classified their previous work couldn't be discussed even within secure facilities. The Adaptive Stealth Development Program represented Elena's transition from solving existing technical problems to creating revolutionary capabilities that would determine American strategic superiority for generations. Her expertise had evolved from maintaining aircraft to designing technologies that could reshape the fundamental nature of aerial warfare itself. Elena's adaptive stealth program achieved its first major breakthrough 18 months into development, when her team successfully demonstrated real-time electromagnetic signature modification in laboratory conditions. The prototype system could analyze incoming radar frequencies and adjust aircraft electromagnetic properties within nanoseconds, creating a dynamic stealth capability that rendered conventional detection methods essentially useless against properly equipped aircraft. The frequency response times exceed our most optimistic projections, reported Dr. James Liu, Elena's lead systems engineer, reviewing test data that showed electromagnetic adaptation occurring faster than enemy radar systems could process reflected signals. Foreign detection systems would be tracking ghosts while actual aircraft remained completely invisible to their sensors. Elena watched the demonstration with satisfaction that came from witnessing theoretical concepts become operational reality through years of intensive research and development. The adaptive stealth system represented a fundamental leap beyond static radar absorption technologies, creating dynamic capabilities that could counter any detection method adversaries might develop for decades. The Pentagon Evaluation Committee arrived for classified demonstrations that would determine whether Elena's adaptive stealth program received authorization for flight testing with actual military aircraft. The stakes were enormous. Successful validation would launch production programs worth hundreds of billions of dollars, while failure could delay American stealth advancement for years, during which foreign adversaries continued developing countermeasures. General Morrison personally observed the comprehensive testing protocol that subjected Elena's adaptive stealth system to simulated radar attacks representing every known foreign detection capability. The system performed flawlessly, adapting to each new electromagnetic challenge, while maintaining complete invisibility to detection attempts that would have revealed conventionally equipped stealth aircraft. This exceeds every performance requirement we established for next-generation stealth capabilities, Morrison announced to the evaluation committee after reviewing test results that demonstrated American technological superiority that foreign adversaries couldn't match with any currently known methods. Elena's adaptive system creates strategic advantages that could maintain American air superiority indefinitely. Elena felt professional pride that transcended personal achievement, knowing that her work would protect American military personnel during future operations while ensuring that democratic values could be defended through superior technological capabilities, rather than larger military forces that impose greater human costs during conflicts. Flight testing authorization came within days, along with assignment of the military's most experienced test pilots and access to aircraft modified specifically for evaluating experimental stealth technologies under operational conditions. Elena's adaptive system would face its ultimate validation during actual flight operations that subjected every component to stresses that laboratory testing couldn't replicate. Major Lisa Rodriguez, who had validated Elena's original harmonic resonance modifications, was selected to conduct adaptive stealth flight testing due to her exceptional ability to evaluate experimental aircraft systems under conditions that revealed problems other pilots might miss. Her involvement provided continuity that connected Elena's current breakthrough to the foundational work that had established her reputation within military aerospace circles. The adaptive system integration is remarkably smooth, Rodriguez reported during initial flight operations that tested basic functionality before progressing to more challenging scenarios. Aircraft handling characteristics remain unchanged, while electromagnetic signatures shift continuously in response to simulated threat detection attempts. Elena monitored flight test telemetry from the Mission Control Center, watching real-time data that showed her adaptive stealth system performing exactly as theoretical calculations had predicted. The aircraft was demonstrating invisibility against detection methods that would have revealed conventionally equipped stealth fighters, validating years of research and development through successful operational performance. The most demanding test phase involved Rodriguez flying missions against American radar systems specifically configured to defeat traditional stealth technology, creating the closest possible simulation to combat conditions where foreign adversaries would deploy their most sophisticated detection capabilities against American aircraft conducting critical operations. No radar contact throughout the entire mission profile, announced the test controller after Rodriguez completed flight operations that had subjected Elena's adaptive system to detection attempts designed to reveal even the most advanced conventional stealth aircraft. The adaptive signatures made the aircraft completely invisible to radar systems that would have tracked traditional stealth fighters continuously. Elena's success attracted immediate attention from international allies who recognized that American adaptive stealth capabilities could influence global military balances while providing strategic advantages that would benefit democratic nations during conflicts with authoritarian adversaries who were developing increasingly sophisticated military technologies. The British Prime Minister personally requested briefings on adaptive stealth technology during his next state visit, while Australian and Canadian defense ministers submitted formal requests for technology sharing agreements that would allow their military forces to benefit from Elena's innovations. During joint operations with American units, Elena found herself consulting on international agreements that would determine which allied nations received access to adaptive stealth technology while ensuring that American strategic advantages were maintained even when advanced capabilities were shared with trusted partners who contributed to global democratic security initiatives. Foreign intelligence services responded to Elena's adaptive stealth breakthrough by intensifying efforts to acquire technical details through methods that included attempted recruitment of personnel with access to classified research facilities and cyber attacks against computer systems that stored developmental data about electromagnetic signature modification techniques. Elena's personal security was upgraded to levels typically reserved for senior government officials whose knowledge represented strategic national assets that adversaries would use any available methods to compromise or neutralize. Her daily routine now included counterintelligence protocols that reflected the international significance of her technological expertise. 5 years after her transformation from anonymous maintenance technician to America's foremost stealth technology expert, Elena stood in the Pentagon briefing room where she had first presented her adaptive stealth concept to skeptical military leadership. Today's audience included the Secretary of Defense, Joint Chiefs of Staff, and allied defense ministers who had gathered to witness the formal announcement of adaptive stealth systems across the entire American military aircraft fleet. Elena Vasquez has fundamentally altered the trajectory of aerospace warfare through innovations that maintain American strategic superiority for the foreseeable future, Secretary of Defense William Harrison announced to the assembled leadership. Her adaptive stealth technology represents the most significant advancement in military aviation since the development of radar itself. Elena accepted the recognition with characteristic humility, understanding that her individual contributions had been amplified by teams of talented engineers and supported by institutions committed to maintaining democratic security through technological excellence. Her success demonstrated that expertise could emerge from unexpected sources when properly recognized and developed through opportunities that valued capability over credentials. The deployment statistics were staggering. Over 800 American military aircraft had been equipped with Elena's adaptive stealth systems, creating a strategic advantage that foreign adversaries couldn't counter using any currently known detection methods. The technology had been successfully integrated into fighter jets, bombers, reconnaissance aircraft, and transport planes without compromising performance or operational effectiveness. International demand for Elena's expertise had evolved beyond military applications to include civilian aerospace companies seeking to incorporate adaptive electromagnetic technologies into commercial aircraft designs. However, Elena maintained her focus on national defense applications while carefully managing technology transfer to ensure that American strategic advantages weren't compromised by commercial competition. The civilian applications are tempting from a financial perspective, Elena confided to Dr. Chun during one of their regular collaboration sessions. But maintaining American military superiority requires keeping the most advanced capabilities within defense programs that can protect the technological advantages we've worked so hard to develop. Elena's influence had expanded to include mentoring the next generation of aerospace engineers through classified training programs that identified personnel with exceptional analytical capabilities. Her informal educational initiatives had created a community of specialists who understood electromagnetic theory at levels that previous military training had never achieved. Young engineers and technicians sought assignment to Elena's programs, specifically for the opportunity to learn techniques that weren't available through conventional military or civilian education. Her reputation for developing talent had made her facilities among the most competitive assignments in military aerospace careers. Elena has created more than technological breakthroughs, observed Colonel Sterling during a Pentagon leadership meeting. She's established educational foundations that will continue advancing American aerospace capabilities long after her individual career contributions. Her greatest legacy may be the people she's inspired to pursue excellence in electromagnetic engineering. The international recognition culminated when Elena received the National Medal of Technology and Innovation during a White House ceremony that acknowledged her contributions to American technological leadership. The award represented official validation of expertise that had once been dismissed by colleagues who couldn't recognize capability beyond conventional assumptions about qualifications and backgrounds. Elena's acceptance speech focused on the FICO's importance of supporting innovation regardless of its source, emphasizing that breakthrough technologies often emerged from individuals whose potential wasn't immediately obvious to institutional hierarchies that valued credentials over actual problem-solving abilities. Foreign intelligence agencies had eventually abandoned attempts to acquire Elena's adaptive stealth technology through conventional espionage methods, recognizing that the theoretical complexity and manufacturing requirements exceeded their current capabilities by margins that would require decades to bridge, even with access to complete technical documentation. The failure of foreign countermeasure programs validated Elena's original assessment that adaptive electromagnetic systems represented technological advantages that couldn't be easily reversed engineered or defeated by adversaries who lacked the foundational research infrastructure necessary to understand and replicate her innovations. Elena's current research focused on next-generation applications that could extend adaptive principles beyond electromagnetic stealth to include acoustic signature modification, thermal camouflage, and even gravitational field manipulation for aircraft that could operate beyond conventional physics limitations. Her work continued pushing the boundaries of what seemed possible through aerospace technology. The laboratory facilities had expanded to include experimental capabilities that explored theoretical physics applications for military aviation, creating research programs that investigated technologies decades ahead of anything currently acknowledged in public aerospace development initiatives. Elena's team now included theoretical physicists alongside traditional aerospace engineers, reflecting research directions that required interdisciplinary expertise spanning multiple scientific fields that hadn't previously been integrated for military aircraft applications. As she reviewed progress reports from research programs that could redefine the fundamental nature of atmospheric flight, Elena reflected on the journey that had transformed her from underestimated maintenance worker to nationally recognized technology leader whose innovations influenced American strategic capabilities at the highest levels. Her story had proven that excellence couldn't be confined by conventional expectations about expertise, and that the most important technological breakthroughs often came from people who were initially overlooked by institutional hierarchies that failed to recognize capability when it appeared in unexpected packages. The maintenance technician had become a legend through quiet competence and unwavering dedication to protecting American interests through superior technology that would influence global security balances for generations to come. 10 years after that first morning when Elena stepped off the transport bus as an underestimated maintenance technician, she found herself standing before a different kind of audience entirely. The auditorium at MIT was packed with aerospace engineering students, their faces reflecting the same hunger for knowledge that had driven Elena throughout her remarkable journey from invisible support personnel to America's most influential stealth technology innovator. "The most important lesson I can share with you today," Elena began, her voice carrying the quiet confidence that had become her trademark, "is that expertise doesn't announce itself with credentials or demand recognition. Through hierarchy, it reveals itself through consistent excellence, patient observation, and the courage to speak truth even when others can't see beyond surface assumptions." The students leaned forward, captivated by someone whose story had become legendary within aerospace circles, but whose humble presence contradicted every stereotype about technological genius and military innovation. Elena had requested this speaking engagement specifically to inspire young engineers who might be overlooked by institutions that valued conventional qualifications over actual problem-solving capabilities. When I first analyzed that harmonic resonance problem, I wasn't trying to revolutionize stealth technology or prove anyone wrong about my qualifications. Elena continued, sharing insights that went beyond technical achievements to address the human elements of innovation. I was simply applying knowledge I had developed through years of careful observation, doing work that needed to be done, regardless of whether anyone would recognize my contributions. The audience included not only students, but also faculty members, whose own research had been influenced by Elena's breakthrough methodologies. Several professors had restructured their electromagnetic theory courses to incorporate principles that Elena had demonstrated through practical application rather than abstract mathematical derivation. Dr. Sarah Mitchell, now serving as Elena's biographer with Pentagon authorization to document her story for future aerospace professionals, observed from the back of the auditorium as Elena fielded questions that revealed the depth of her influence on educational approaches throughout the engineering community. How do you handle working in an environment where your expertise might not be immediately recognized? Asked a young woman whose own experiences with institutional bias were evident in her carefully phrased question. The greatest victory is not personal vindication, but institutional change that prevents others from experiencing the waste and frustration that I endured, Elena explained during a mentorship session with junior female soldiers who sought guidance about career development in traditionally male-dominated military specialties. The memorial wall in Elena's office displayed photographs and letters from soldiers whose lives had been saved through precise shooting techniques learned in her training programs. Their testimonials represented the ultimate measure of success for someone whose skills had been developed through combat experience and refined through institutional struggle that had nearly destroyed her career. Elena's story continued to evolve as she shaped the next generation of military marksmen, while contributing to institutional reforms that improved personnel utilization and operational effectiveness. Her legacy would be measured not only through personal achievement, but through systemic changes that ensured exceptional capabilities would be recognized and utilized rather than suppressed through bureaucratic indifference. The woman who had been relegated to cleaning weapons while others trained with systems, she understood better than anyone had become the instructor who prepared the military's most skilled precision shooters for combat operations where lives depended on accuracy, judgment, and moral courage. Her journey from institutional exile to professional leadership demonstrated that competence ultimately transcends politics, that truth eventually overcomes prejudice, and that exceptional individuals can create lasting change through persistence, skill, and unwavering commitment to excellence. 3 years after her vindication, Captain Elena Vasquez received an unexpected phone call that would bring her story full circle in the most remarkable way imaginable. The voice on the other end belonged to Lieutenant Colonel Marcus Thompson, the same officer whose poor judgment in Kandahar had derailed her career and whose institutional protection had kept her buried in the armory for 18 months. Captain Vasquez, this is Colonel Thompson calling from the Pentagon. His voice carried a humility that she'd never heard during their previous interactions. I'm requesting your professional consultation on a matter of critical importance to Special Operations Command. Thompson explained that he'd been tasked with developing new rules of engagement for precision shooting operations in complex urban environments where civilian populations created moral and tactical challenges similar to those Elena had faced in Kandahar. The military had finally recognized that her decision-making during that controversial mission represented exactly the kind of ethical judgment they needed to institutionalize. Captain, your refusal to fire in Kandahar has become a case study In military ethics courses throughout the special operations community, Thompson continued, his admission representing a complete reversal of his previous position. We need officers who understand that sometimes the most courageous action is the decision not to pull the trigger. Elena felt a profound sense of closure as she listened to Thompson's request for her expertise. The same judgment that had nearly destroyed her career was now being sought by the institution that had punished her for demonstrating moral courage under impossible circumstances. Her vindication was complete, but more importantly, her experience would help prevent other soldiers from facing similar ethical dilemmas without institutional support. Colonel Thompson, I'll be happy to contribute to doctrine development that helps soldiers make ethical decisions under combat conditions. Elena replied, her voice carrying the professional composure that had sustained her through years of institutional struggle. But I have one condition. Any training program must emphasize that following conscience sometimes requires challenging authority, even when that challenge carries personal costs. The conversation ended with Thompson's agreement to Elena's terms and his acknowledgement that her case had forced the military to examine how institutional pride could interfere with mission effectiveness and ethical decision-making. Her story had become more than personal vindication. It had catalyzed systemic change that would benefit generations of soldiers facing similar moral challenges. Later that evening, Elena stood on the observation deck of the Advanced Marksmanship Training Center, watching the sun set over the Montana mountains that had witnessed her journey from exile to leadership. The rescued climbers had sent another letter thanking her for the precision supply delivery that had saved their lives. But Elena knew that her greatest achievement was the institutional change that her experience had created. Lieutenant Chun approached carrying Elena's personal Barrett M82, the rifle that had been locked away for 18 months, but now served as her primary instructional tool. Captain, the evening precision shooting class is ready for your ballistics demonstration. The new recruits are eager